I will kick things off. Welcome to not the second meeting ever of the Jersey City Java User Group. I'm sure that's not true, but the second meeting since it has been revived by someone who actually has programmed in Java. I'm not sure what it was doing before, but I'm not sure it was this kind of stuff. So last month for our first reconstituted meetup, we had G-Paw Hill, who spoke not specifically about Java, but specifically about change, which is what we're all in the business of. And I thought for our second meetup, since this is a Java user group, we should get a little more Java specific. And again, this is more like an object-oriented talk, I think. Ted will tell us more about it. But I bet from a picture on this first slide that Java is involved. So let me mention a couple more things first. We will have another meeting in December, in mid-December, before it's the holidays, in case that makes a difference this year. Who knows? And so we'll announce the speaker pretty soon for that. And I am recording. So if you don't want to be recorded, make sure that your microphone is off, your camera is off, and please let me know in case you already were on camera and I can edit that out before I post this video. If you will have questions during the talk, Ted, what would you prefer? People type it in chat and I'll pick spots to ask you? Okay, I'll do that.
Yep.
And then one quick other thing, which is that Barry, who is on the call here, is actually in the New York area. I think you were the only one last time who raised your hand that you're actually in the New York area right now. And you're involved in a couple meetups also of a Java flavor in the New York metro area. Can you take a minute and tell us what those are?
Yeah, so if you remember the word JavaSig, JAVASIG, then you can either visit javasig.com, which is one of my meetup groups, or javasig.org, which is a different one. And when I say my meetup groups, I don't mean that I'm not the leader exclusively of either of them. I'm the co-leader in both of those groups. javasig.com is the New York JavaSig. It's, I think, been around longer than any other Java user group. Basically 1995, has 8,000 members, and we present about usually 2 different meetups a month. One of them is a regular presentation and another is a workshop. And so they're available, Eventbrite is a good place to look for them, but if you go to javasig.com, you can probably find them easily. And all our previous meetups are on YouTube, and we've just got a whole, big thing. Okay, javasig.org, that's the newly renovated Garden State Java user group. It has been around in a different form since 2001 as the Amateur Computer Group of New Jersey's Java user group. And we're just starting up and revving. And we've got a lot of good stuff planned also. So please join us. Please, please, please.
Great, thank you. I put the links for both of those in the chat. So again, for questions, you can type in that you have a question, or you can type in the question. And then Ted and I will make sure that you get a chance to ask at a good time. One more thing, and that is that I want to tell you a little bit about Ted, in case you don't already know. And then it's going to go over to Ted. Ted is an independent Java trainer and coach. And I can say personally, when he's come to talks or workshops or sessions that I run, I learned something about how to run a talk or workshop or session. He is very deliberate and very serious, but not only serious, but also very serious about how people really learn and how to make information processable and acquirable. And I think this is a new talk, so it may not have the same track record as all of his other talks and presentations that he's done, but I can tell you what went into it because I know Ted. And I bet that this is going to be a really good learning experience. So without any further ado, because that was enough ado, I'm going to hand it over to Ted. Ted, thanks for coming and speaking for us, and the floor is yours.
Thanks, Amitai, and thanks everyone for coming. As Amitai mentioned, this is a new talk, but it's actually a lot of it came about through actually a course that I've been delivering a lot of over the past few months, which I call Make Your Code More Testable. And so to give you a little bit more background about me, and yes, I'm a Java trainer coach, but I have a very, 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 very test-focused way of looking at things, where really everything I do these days, especially both teaching, coaching, but also development. So one thing that I didn't mention is I also do a lot of live coding. Although not recently because I've been so busy doing online training, but I do a lot of live coding on Twitch. And so you can see I'm Jitter Ted everywhere on the socials, on Twitch, Twitter, YouTube, it's all Jitter Ted. And on Twitch, what I do is for 2 to 3 to 4 hours, I code using TDD, all the good practices. And what that's allowed me to do is really take a step back and look at what is my development process. A lot of times, especially for us experts, we do things intuitively. We don't really maybe reflect a lot on what we do. And so that live coding, since it's on video and recorded, plus all the online training I've been doing recently has been recorded, it allows me to sort of take a step back and look at what am I doing? Why am I doing that? Is that the right thing to do? And so this thing about primitive obsession, which I'll go into what that is, really came out of, it's actually the sort of became the fundamental piece of the course, but I found myself just becoming obsessed about it and seeing it everywhere. So let's get into that. And let's click on the right button. There we go. So as mentioned, ask questions as you need to. There should be more than enough time for me to answer questions. As I mentioned, since I live code on Twitch, I'm really used to keeping an eye on chat and sort of noticing when there's a question. So don't feel that, don't hold back. So primitive obsession. And as Amitai mentioned, like this is a Java specific, the way I solve this and the way I look at this and the examples I show are all going to be Java. But any language that has really good sort of static typing at compile time, so your C sharps, things like that will be applicable. Languages like JavaScript, not as much, although some of it might apply. But really, I've been doing Java for 25 years. I actually remember Frank Greco from way back when in the mid 90s, because that's where I was. I was in New York when I first started working with Java. So me and Java go a long way back. And so this code smell, and if you're not familiar with code smell is actually came up was first written about in the refactoring book from Martin Fowler from '99, which is one of the top 5 books that I'm constantly recommending. And so he and Kent Beck, mainly Kent Beck, came up with the term of this idea of a code smell, right? You're looking at code, it's not quite right, something's off. And so this idea of giving it the sniff test, there's something not quite right. And so what primitive obsession is all about is, let me just move a window out of the way. Too many windows. So the first thing we look at is answering the question of what is a primitive. And this is a really interesting question because most people, when I ask it, they probably come up with the typical answers in Java of int, long, and char or char, depending on how you pronounce it. Maybe Boolean, although that one is interesting. Maybe string. But what doesn't often come up are the data types, collection classes, things like that, like list, map, and set. And what's interesting is when years ago, I remember distinctly coming to the conclusion that anytime I was using a map in a class, it seemed like it always made sense to pull it out into its own class. And I don't think and I certainly hadn't realized the connection to sort of primitive obsession or anything like that. It just seemed like every time I created a map, and oftentimes wrapping it inside of a class made a lot of sense. So in terms of, these are sort of what the primitives are in this code smell. Where we see them are especially in instance variables, right? So I've got a class, it's got some instance variables, they're ints, longs, whatever. That's where we find them. But what's interesting, and this actually came or was crystallized actually when I was teaching an early version of my Make Your Code More Testable class, is both method parameters and return values can suffer from this as well, and it leads to some interesting things that we'll look at. What is not primitive obsession is local variables, right? If you've got a method and it declares an int or long internally, I don't necessarily consider that by itself to be suffering from primitive obsession. So what's wrong with using primitives? So one problem is that we see that we mix responsibilities. So we got a class and it's got 5, 6 instance variables. The problem is that even if they're nicely contained inside that class, there's sort of this mixture of responsibilities that are dealing with things like validation and constraints and so on. And so that's one problem. And we really want our classes to be as small as possible and have few responsibilities. And things like validation and constraint checking and things like that around an instance variable kind of mixes up the responsibilities a bit. The other thing is they're not self-documenting. You're really leaning heavily on the variable name to provide information about what is this thing, and then looking around the code to see, okay, I have this variable called stock. What does it mean? What does it do? What are the constraints? And then this leads to dispersed logic, both inside and outside of the class. So an example of this is this variable here. In fact, these two variables, but we're gonna focus on this
how
one.
they all work. So it's an excellent mechanism for ensuring that you have, a good amount.
Okay, somebody unmuted themselves. So here, this is ingredient, which is part of this coffee vending machine, this drink machine, and it's got this variable stock. And so when we look at this, we don't know a lot about it. And you may be like, well, what is this? Okay, it has to do maybe with inventory levels or something like that. It's not the greatest name. And it's an int, which leads us to thinking that it's just unconstrained. And so we don't know what the constraints are. We don't know what kind of validation there is. So we'd have to look around the code to figure that out. And so it leads to this dispersed logic both inside and in a lot of cases outside. And we'll see that looking at primitive obsession as the code smell and sometimes even solving it actually leads us to another code smell that we'll look at that you may be familiar with, which is feature envy. But we'll look at that later. So if use of these unconstrained variables is not a great thing, so let me talk a bit more about that. When we think about the variables, the instance variables that we're using inside to hold state, right? When we're thinking about these primitives, there really is a huge difference between an unconstrained number, right? Any unconstrained variable, but in this example, an unconstrained number, right? I mean, look at its range, right? It goes from negative 2 billion to positive 2 billion. But it's pretty rare that we need that entire range. Yet we throw around ints as if, that's okay. And so really what we want is, so for example, one of the example programs that I use a lot in my training is a blackjack implementation. And so one of the things you can do in blackjack is place a wager, place a bet. And clearly that has to be constrained. And so sure, we can put validation checks around it, we can do that, but that leads to the code being hard to read. And by hard to read, I mean like instantly I want to be able to tell when I look at this variable, what is it? Right? Not just by its name of the variable, which totally depends on who wrote it. And names drift, names are hard, all that kind of stuff. But what we really want to do is put into the type itself, create a class, put it into the type itself, all the information about it, both what its constraints are, what the validation is, as well as possibly behavior that's associated. So we'll look at that as well. So we'll come back to this specific example, but I wanted to sort of give you a sense of anytime you're using an int, a long, a char, a Boolean even. I mean, Boolean is kind of interesting, less so around constraints, but more about assigning meaning. And so one of the things I harp on in my classes and pretty much everywhere I talk about is that we need to assign meaning to things so that they're easier to read. Right? Because we read a lot of code. We're going back and forth and going all over the place in code, either that we haven't seen it in a while or it's changed since we last saw it, and we want to make it easier to read. And so one of the ways we can do that is create a type and then put all of the meaning, all the information about that into that type. And so Barry mentions in Ada, you can declare an int with constraints. I remember in Visual Basic, you could do that as well. And there are some languages where you can create an int with a specific range. And range is often one of the constraints that we have on our primitives. So the way we fix primitive obsession is we create new types. And one of the interesting things that I encounter when I suggest this to folks is, but isn't that expensive? Isn't that going to make things harder to read? I'm going to create a class for this int. Are you kidding me? What, isn't that going to make things slower? And all these objections, I feel like a lot of, they were true once, maybe, right? Maybe back in 95, 96, it was true that, using a class instead of an int might have been a performance problem or might have, caused other issues. But we're in 2020, almost 2021. Java's pretty fast. Java's ability to optimize things and do all sorts of good stuff, from garbage collector to compiler optimizations to runtime optimizations. Like, that's not an issue. And I always tell people when they ask about performance issues, I say, like, look, the performance problems you're going to run into are not this. The ones you're going to run into are deserializing that JSON from that big HTTP API call. That's where your problem is going to be. And so how about we spend some effort, even if it slows down, a hair of a %, but if it makes it more readable, that's a win in my book, because we can always fix performance problems by measurement. And the other thing is mainly that people still don't know how to code Java in a good object-oriented way. And so this sort of like, well, it's going to be harder to read if all the information is spread across classes. I'm like, it might be initially. Yes, that reading code spread across 10 files is going to be harder than reading if all those 10 files were in one file. But you don't have to read those other files very often if it provides a name and if you know what it does. And so, in fact, it'll be easier to read because instead of having 100, 200 lines of code, you're going to have 10 lines of code or 20 lines of code. So those are some of the objections I get, and it's just interesting to see how these kinds of things persist. So in order to solve primitive obsession, we create new types, we create new classes. We give them a name, and then we put all the information about it into that new type. So I mentioned type and not class because one of the first ways to encapsulate this information and give it a name is an enum. So enums are great ways to take care of primitive obsession where you have limited options that you know what they are at coding time. Right, so some examples are a playing card suit or rank, right? Heart clubs, right? Spades, diamonds, that's it in a typical standard playing deck, right? Ace through king, maybe joker, depending, right? It's known, it's not large, it's not going to change dynamically. Things like game outcomes, right? If I beat the dealer, if I lost, if I got blackjack, or from another application I'm working on for options trading, a put or a call, right? All these things should be enums, and it's not just because we want to limit the choices, but we give them a name, and that means that they're easier to work with. And so what we get from is instead of using strings and comparing strings, which I see a lot of code doing that, let's put them into enums. The other thing is that often when we have strings, we're doing logic on them, right? So for example, this is sort of pre-refactor. This is code from the blackjack game representing a card, and so we're storing a string for suit and a string for rank. And so here we see some code in this card. It's well named. Might be if you're not familiar with playing cards, it might be a little bit getting up to speed of why is the JQK 10, but not terribly difficult. But this is logic against things that are basically static. And so which by turning them into an enum, oftentimes you get rid of yes, as Zeb mentioned, stringly typed programming, right? Where we're using strings a lot and comparisons to make decisions, and we should stop doing that. So what we do instead is we convert it into an enum. And since a 3 is always going to have a value of 3 and a k is always going to, as a king, is always going to have a value of 10, there's no point in having any logic at all. Right? Why do comparisons or any kind of logic if you know what it is? And so then the enum just, when you ask it for its value, it just returns a constant. And so this is something that happens when you turn these primitives into constants, and really looking closely at your strings. Can I, or your ints, but typically it's strings. Can I turn this into an enum? Can I get away from using strings and comparisons? And it turns out in this class, suit as well easily converted into an enum, and asking it if it's a red card or a black card for coloring purposes, for display, then again becomes a constant because diamonds with a standard deck are always red. So the next way to get rid of primitive obsession is value object. And so value object, right? This idea, this name of I guess you'd call it a pattern, goes way back, but for me, sort of came back into usage and popularity with domain-driven design. So the idea of a value object is it has no identity separate from the value itself, and we'll see some examples. And so here, where you might be thinking about an enum, but wow, there's lots of choices, and at runtime we might make those available. So an example might be an address, right? Or even a zip code. It doesn't change very often, but it needs to change. It may change dynamically while the system is running. We may not know all of those zip codes up front. And so an enum is probably not a good place for it. But certainly we can give it a name, and instead of storing that zip code in a string, I sure hope you're not storing it in an int, there's no reason to store it in a string. You're not create an object out of it. So again, for anything that's using an unconstrained, there are always these constraints. So I mentioned this one before, right? For a wager, we're not using the entire range. We're using some constrained range. For a date, so for my options trading system, one of the things that's an important attribute of an option is when does it expire? But it's not any arbitrary date, right? So local date in Java, actually, I recently learned that it can go from negative n number of nines to positive n number of nines. I didn't realize the range was that wide, but apparently it is. We clearly don't always need that range. And in fact, for expiration date, in fact, we don't even need a small range. It's basically a bunch of specific dates. So it's basically a set of available things. And even here, they go away. And so all that code around, is this still a valid thing? Is this still in the future? Maybe it retrieves it from some external system, but I want to represent it as something that is only one of these possible dates. And so by putting this into our code, immediately I can see, instead of holding strings for this information, I'm holding a type that gives me a great name and helps me at as much as possible at compile time not to make a mistake. Because a lot of times when we hand parameters around, if it's just a local date and we're passing around, it's possible that they get confused for something else. In one place, it's being treated as an expiration date, in another, it's the transaction date. But if they're both local dates, there's no way to tell the difference. So even if you do nothing else, by encapsulating it and giving it a name, you immediately provide a way at compile time to make sure that the parameters you're passing around are the correct ones. So another example of this is, for example, identifiers. Right? We use identifiers all over the place in our entities. And I remember when I first came across a use in Vernon Vaughn's book on implementing domain-driven design. He uses IDs as objects, so customer ID, user ID. And it's basically a thin wrapper around an int or a long. And it took me, I didn't quite see what the purpose was. But later on, you're passing around multiple IDs. And if they're passed around as these, raw, sometimes I refer to them as naked, unconstrained types, ints and longs, it's very easy to get them confused. And so even for things that you might think, well, there's no constraint, right? It's created, I'm going to pass it around. There's not really much validation checking because it's immutable, that kind of thing. Even there, just wrapping it and giving it a name is really powerful. And so other value objects like this, we probably already use, but these are all solutions to sort of primitive obsession. Moving to money, a money class, right, even itself contains things like currency and amount. Birth date, right? I want to tell the difference between birth date, transaction date, and expiration date. These are all dates, but I want to give them a name that is significant to compile time. And so this is where I always say it's like Java has static typing. So let's leverage it. Let's use it. Color, if you're familiar with value objects, this one's an obvious one. And as I mentioned, identifiers like user ID and customer ID. So those take care of sort of the ones that are kind of immutable, right? They're not going to change at runtime. Even dates, if you as you know, they're by themselves immutable. You don't usually do operations on them. You pretty much create a new one from another one. But sometimes you want stateful types. So something where, for example, you can track inventory. So inventory is going to have constraints, but it's also going to have a limited set of operations, right? Commands that you can do to it, requests that you can make of it, and queries that you can ask it for information. An example we'll look at also is a blackjack hand and order quantity. And so again, all these things you might just have as numbers or strings or lists buried inside of another class. And so in addition to sort of mixing these responsibilities, it can often also make it harder to test. So let's take a look at that. So here we've got a blackjack game class. It's got these two hands, right? Nicely typed, right? It's got a list. It's a list of cards. A card is a nice, is a nice object. But these are just lists. And so there's a lot of code around interacting with these things. And we can see if we just look at the usages, there's, adding, drawing a card from the deck and adding that to the hand. There's logic. And so when I look at these kinds of things and I look at logic, I look at comparisons, I look at, comparisons, I look at things like display, but I'm mainly concerned about logic. Those are the big things for me. Those indicate that there's this smaller class that is wanting to come out. And so testing something like this, I mean, this is fairly readable. This, maybe it could use some further refactoring, but this might be fairly readable. And you could possibly make this more readable doing some simple refactoring by converting this into a query like, is busted. Right, so now this is readable, but this is still doing operations that, is this really the responsibility of game? And so by looking at instance variables for these primitives that we might be obsessing over, right? Not in a good way. So I obsess over them in a good way by looking for them and saying, can I encapsulate this in a type? Can I encapsulate this in a class that has operations? And so what I'd want to do is I'd want to pull this into a thing by itself. And so we'll see an example of that. So there's sort of, I classify primitives in basically two types. There's sort of scalars, right? Our ints, longs, Boolean is kind of scalarish, and then basically collection, right? Data types collections. And so I want to encapsulate both of those. Now, what's interesting is if we look again at a reference to this, if you imagine, hey, if there were a hand class that encapsulated this, all this code would be operating on information from that other class. And so if you're familiar with the other code smell that I mentioned, feature envy, you'd say, wait a minute, that's feature envy. And so what's really interesting is that once you start looking at primitive obsession and start solving it by moving these things into their own classes, you end up exposing feature envy, which is basically, this code shouldn't be here. This code belongs to hand. Why is it here? And so you start recognizing these things, and so to me, these code smells, primitive obsession and feature envy, almost always go hand in hand. Fixing one reveals another, and you fix that, and you've actually solved quite a lot of problems. But the other thing I wanted to mention is this is hard to test, right? So remember, the lens how I look through everything these days in terms of coding is through how testable is this? And this is horrible to test. I can tell you, I've tried. This is not very testable at all. Now, there's a number of reasons to, well, how do you test for system out println? But that aside, this behavior, right? This is domain behavior. This concept of the value of a hand being more than 21, there's a term for that. It's called being busted. But that's, it's sitting here innocently saying something greater than 21. And so this is really hard to test. Even if I pull it out into its own method that says, is busted, now I've got it's private, and the rule I have is you don't test private methods. But let's say, let's relax that because I'm in the middle of a refactoring. So even putting that aside, this is really hard to deal with. I got to instantiate a game, and I got to figure out how to set the dealer hand to the thing I want, and then I can finally call this method. And so I see this over and over again in code, this feeling like you're testing at a distance, right? That you're trying, you're testing a light switch with literally a 10-foot pole. Like, boy, wouldn't it be easier if I could just flick the light switch with my hand instead of this 10-foot pole that gets in the way? And so extracting things out is a good first step, but when we pull things out into their own types, magically, it makes things more testable. My favorite other example, sort of related, is let's say you're trying to test a light bulb, and all you have is a lamp. So you put the light bulb in the lamp, and you walk over to the wall switch, and you flick it on. It doesn't go on. What's wrong? Is the light bulb broken? Is the lamp broken? Is the wiring broken? Is the circuit breaker open? Does the light switch work? Right. And so this is that at a higher level, the problem we have with testing is there are often so many intermediate objects, right? Like fixtures, a test fixture. Do you trust your fixture? Is that there's so many other objects in the way. Now you do need to test, multiple objects working together. Did I wire them up correctly? Did they pass parameters correctly? But if I'm trying to test hand, whether it's busted or not, why am I going through this other work of game? And so a lot of times people get stuck and it's like, yes, I know this is hard, but what do I do? I don't know what to do. And so for me, looking at primitive obsession, what are these primitives? Let's pull it out into a new class. Let's drag along all the behavior that's with it. And so that's what's really interesting. So we'll look at an example of that. So as I mentioned, feature envy is often the code that's revealed. And so another example of feature envy is this, right? So this is code in this drink machine, but it's basically doing these things in reduced stock. It's like this is sort of almost the worst kind of feature envy, although it's the best because it's really obvious that it's feature envy. And so here it's basically grabbing, hey, ingredient, what's your stock level? What's your inventory level? And I'm going to do some calculation on it and then stuff it back into stock. This one is a little bit more subtle because, oh, what's the harm in getting the stock level? Well, it's because you're doing a comparison. And that's in the wrong place. And so by pulling things out into separate classes, this feature envy is revealed, and then we can solve the feature envy. And by solving the feature envy, that, first of all, is just better OO, but it also makes things more testable, which to me, they're almost two sides of the same coin. There's a discussion in one of the Slacks I'm in where it's like, sort of the conclusion is like the more OO you make your code, and by OO, really truly encapsulate things, really tighten up that encapsulate, and we'll look at that in a bit. Really tighten up that encapsulation, right? And so Mike says getters, setters, right? So getters and setters are evil, and it's not because there are two reasons, but one of them is the mindset of why are we revealing all this information? So I'll come back to that when we look at this example. But this idea of if we really, I always think of objects as having this surface area, right? That they're like a sphere. And the more information they expose to, the bigger the sphere is. And because, as it grows, it's more complex internally, but we only see the outside. But there's lots there, and that means there's more to test. Whereas I want to really squeeze these spheres into be really small and reveal as little information as possible. And that makes it easier to test, but really that's just good OO. All right, so let's look at an example. So there, as I mentioned, there are two kinds of primitive obsession I look at. One is scalar, the other is collection. So the first thing you do is basically you gather all the usages of your getters and setters, and so you pull all those into the class. And so here we've got this ingredient, and it's got get stock. And so we want to basically stop people from using it, because in order to sort of prepare ourselves to move things over, we want to stop people from accessing this directly. Do they need this information? And so again, we got this static type language Java or similar C#. We've got these wonderful, fabulous, magical tools, development environments. And so let's lean on them. Let's say, okay, hey, IntelliJ, tell me where this thing is used. Well, it turns out the only place this is currently used is for display. Right? So it's used here to basically just display some information. Well, then why the heck are we exposing an int here? That's a lot of information to expose. You might think it's harmless, but I can tell you it's very tempting. The minute somebody who's working on some code is like, I'm looking at ingredient, oh, look, there's a get stock method that returns an int. Let me go use that and use it for comparison or calculation purposes. And instantly they've created feature envy, basically code somewhere else where it shouldn't be. And so by being, and I remember encountering this idea 7-8 years ago and being like, that's kind of ridiculous. But over time, I've come to really appreciate it. Like, and it's this idea of like hiding and encapsulating the information as much as possible, not to prevent and make other people's lives harder, but to allow for freedom to refactor. So instead of returning an int, which I will have to now support forever, if I return a string instead and say, you want stock for display purposes, then I'll do that. And this one shouldn't really do that. And so now this sends the message that this is only for display purposes. In fact, I'd probably rename this to just say, something like that, display stock. Maybe I could come up with a better name, but that kind of gives its indication that this is just for display. You shouldn't have to know the number. And the reason why is you ask objects questions. But by restricting this to, and again, sort of this idea of sort of reducing the surface area, by going from an int, which is this unconstrained variable, to a string, we've changed the character of what this is returning. We've said, this is not for comparison or calculation. This is just if you want to display it somewhere. And so instantly a whole bunch of possibilities have been closed off. And what that allows us to do is then refactor this class. We may not know how we're going to refactor it in the future, right? So this isn't, we're predicting the future, speculative generality, right? Premature flexibility, those kinds of things. It's not. What we're doing is we're saying the more we close off the information that's exposed, the more degrees of freedom we have to change the contents of this class. And especially since I've been focusing a lot on refactoring over the past bunch of years, this idea of not trying to prematurely guess at what the flexibility is, but always try to give myself a path so that I can change it when I figure out what that is. I don't know what change in the future I'm going to need, but by closing off too much, revealing too much information, and this is just basic OO, but again, using primitive obsession and the feature envy and looking and actively looking for these things is great guidance. Evan asks about reduced coupling, and that's what this is, right? So I didn't want to throw the coupling word in, but sure, let's throw in the word coupling, right? The more coupled things are, the less degrees of freedom you have to change things on either end. And so what Evan says is exactly right. We're loosening up the coupling, right? Tying it to a string is much looser, much more loosely coupled than tying it to an int. And I didn't even connect this to primitive obsession actually until I was teaching this class that I've been teaching over the summer. I always thought it was a good idea, but didn't feel like I had a handle on sort of how to communicate it. And now, sort of applying primitive obsession, which was initially intended for these things up here, can also be applied to both parameters. Am I passing in too much? Do I need to pass that? But especially return values from objects. And so this reduces the coupling, and that's what we want from our classes. We want to even not tempt people by more tightly coupling. All right, so let's look at this. So here we've got another place, and so here's the other side of primitive obsession. Maybe you can think about it as a triangle. There are three sides. The base is where fields are using primitives that maybe they don't have to. One side is that we're returning primitives that are tempting and may more tightly couple other people's code to this class. Here's the third one. It's like, do we need this? Regardless of whether it's called a set or not, we're passing in basically, I mean, it's a set. And the set is really the problem. And so we can look at, again, where is it used? Well, it's used in this place, restock ingredient. So this is feature envy again. This is like, well, what's really going on here? What is 10? And why am I doing that? Well, we could look at this method. This might give us a hint. But looking at this line of code, it's like, what's the significance of this? And so, again, going back to one of my heuristics of I want to give things names. I want to provide them with meaning so I don't have to go and figure stuff out. I don't want people to have to figure out, what does this mean? It's very tempting to say, oh, well, I'll make 10 into a constant and give that a name. That can help. But boy, wouldn't it be much more valuable if there was a method on an ingredient that was restock. So I'll extract it. And so what I typically do as a refactoring is I'll extract it to the thing I want, and then I'll move the instance method over to where it goes. So now from the caller side, I see what it's doing. It's looping through all the ingredients and asking each one to restock itself. And so now inside ingredient, it's just restock. And this 10, maybe I need to identify it. There's some duplication. There's another 10 here, so maybe I turn it into a constant. But if this is the only 10, this might be sufficient because we already know what it does because it says restock. So once we've done that, so now nobody else is calling this. And so that leads us to our next step, which is we remove the getters and setters. So this idea of gathering, so often I see primitive obsession and getters and setters go hand in hand, because usually you're getting and setting something that is usually a primitive. And so the first thing I want to do is kind of draw the line around those getters and setters. Pull everything into the class. And then I want to remove them because they don't need them anymore. So we can inline this. And so what's interesting is there's this validation. And so so maybe we can't pull that together. And so now we've got this class. Now it even feels like it's doing two things, right? It's managing ingredients and so on, and sort of converting from external things around recipes, external domain stuff, and then it's dealing with a lot of just numbers. And so now there's things that we can pull in to a separate class. And how we do that, really what we want to do is remove access to the outside. So we can say, all right, well, set stock, we can make this private. And so now nobody outside there's no get stock, and anybody in set stock, that's basically this method here. So it's encapsulated inside this class. And then we move this scalar, right, this stock thing, to a new class. And so we give it a name. Stock may be a really bad name, so maybe we decide inventory level is a better name. And once we do that, then we can start switching over the code to use this new type. And then any place where we might have had a getter that was returning this information, so for example, this, currently referencing an int, we might want it to reference something else. So what we end up with is a class like this. It's clean. There's not a lot here. There's some of the validation I haven't yet pulled over, but now where it's used, it's much more clear what's going on. So if I want to reduce inventory because I'm making a drink, we should reduce the inventory based on this recipe. Ultimately, it figures out what it needs to do and then turns around and delegates the responsibility of tracking that inventory to this other class. Now, if we look at these two classes side by side, and say, well, this is pretty clean, right? I can create an ingredient and do some things with it, right? So think about how I test this. This is testable. But if we look at the one on the right side, right, our inventory level, this is way easier. And the reason why this is easier is this is not coupled to anything, right? This is basically just dealing in ints. Reduce inventory by has sufficient inventory. This would be trivial to write tests for. In fact, you can write tests for it that are like this, right? A few lines of code. But if you think about what it would take to write a test for this method, well, now we've got to deal with recipe, which is important from the rest of the code standpoint, from the domain standpoint, but it's an annoyance from the test because what are we really testing? That we pulled out this information correctly? Really what we want to test is this part, right? Math, calculations, logic, that's what we want to test. But again, this would be testing at a distance. But by pulling it out to its own, by solving the primitive obsession, pulling it out into its own class that has that responsibility, then testing this becomes trivial. And where I always make mistakes is in terms of comparison operators. Is it greater than or greater than or equal? Where's the boundary? And so I want to write a bunch of tests for that. And I want them to be as simple as possible. And you may find that this is reusable. But reusability in OO, for me, is like number 10 on the list. I don't really care about it. If reusability happens, great. But I think people spend too much time thinking and wondering and worrying about reusability when 99% of the time, it doesn't matter. If you're writing a library, fine. But most of us are not writing libraries. At least I hope not. Most of the time we're using them. And so reusability is not a concern. But often what happens is when you pull things out, give them a name, and they start attracting behavior, all of a sudden they may be reusable. Maybe. But that's accidental reusability, which is, nice if you can get it. But otherwise, we now have one place to look for information about how inventory level is handled. How is, what are the constraints? What are we doing here? But also, what are the methods that we have? How can we talk to this thing? So one thing, if you look at this class, you may notice something that's completely missing. We don't expose at all that number, that stock information, this int, because we don't need to. Why should we? If you want to know, do we have enough inventory? You ask it, do you have enough inventory? If you want to say, hey, we've used up some of you, so could you reduce your inventory? Then we do that. This is commands and queries. This is basic OO that I read about in the late 90s in the huge object-oriented software construction book by Bertrand Meyer. And it's kind of weird. Like, I know it's it's like you expect that if it's going to encapsulate this int, that somehow it's going to reveal it, but it doesn't have to. And that's what we want, right? Again, this loosens up our coupling. Maybe it's not an int. Maybe we change it to a long. Maybe we change it to a short because we're memory constrained for some reason and we don't need it. And certainly we could fit 100, or 10, which is our max, into that. And so all these things work together of what do I look for? I look for primitives that are unconstrained. I give them a name. And then I constrain them, and I constrain the way we talk to them, and I pull them into a new type and really sort of squeeze out, what am I exposing? And all the benefits of that is easier to work with because it's more loosely coupled, but also easier to test. And as I mentioned, that's my primary goal. Is it easier to test? And so we end up with classes like this where no more is this class concerned about tracking the inventory and adjusting for it and checking against it and things like that. It delegates that to another class. So Mike asks, so you wouldn't test inventory for quantity, just by the exposed methods. You could totally write tests, Now, where it becomes sometimes inconvenient is you may need to expose some of that information because otherwise it can be possibly hard to test. And so what'll happen is I'll move it over to a new class and I'll really like squeeze out anything that it's exposing. And then I'll have to make the decision when I write a test, wow, this is painful to write a test for. So I'll relax the restriction a bit and I might expose it as a package private method. So they're trade-offs. Is quantity needed that also sign a primitive obsession? Yes. So units is very important, right? Because that's something that we also don't know about. Is what the heck are these units? Now it turns out that in this code, these are literally units. So you sort of think of them as prepackaged ingredients, right? Sort of the K cups in a Keurig coffee maker kind of thing, right? There's 10 of them, and so they're units of things. But certainly if there are units of like, is this fluid ounces? Is this weight ounces? What's going on? That would be inside here, and you'd probably have inventory level then be passed around, or inventory item or quantity, depending on sort of how you're using it. That would be the thing you pass around. And so I always feel like when I pull on this thread of primitive obsession, I get this whole thing, all these benefits, all these things that happen. I pull it. Once I created this class, we start thinking about units. We start finding a place for, oh, this behavior was over here. Now I have a place to put it. And so primitive obsession or not, creating these new types becomes this place where stuff can go. And before it may seem like, well, this code's fine. All of a sudden this class exists and it becomes like gravity, this huge gravity well of pulling in everything having to do with this. And all sorts of code that may have been scattered that you may have had to change in multiple places previously, and you're like, there's nothing else I can do. It's spread all over the place. Now there's a place to put it. As Mike Grizzly says, yes, I could, if I really was concerned about protecting, I could make it as a protected variable or protected method subclass in my test. That's another technique. But I always feel like I pull on this little thread of, I want to make this a little bit more testable. I want to put some names on it. I want to capture its essence. And all of a sudden, stuff that was just spread all over the place now has a place to go. And so to fix collection primitive obsession, it's really interesting. I won't go through all the steps because they're somewhat mechanical. But what you do is you basically say, okay, what is this collection field? What do I want to create and sort of grow into a new class? So I see Jessica, and I always think of like stuff growing into something, and that's really what happens, right? So you can either think of it as a gravity well or something that grows and starts, as your program grows, it has a place to grow. And so we put in this little seed of, we move the collection to a new class, but we access it via a getter. So it's still not much has changed, right? We just have this new type. It just has a collection, but it has a getter, so it doesn't encapsulate anything. But now it's sort of this anchor, and you just follow, where is it being used? And you start pulling all that over. Yeah, Sprout class. Yeah, although in a somewhat different way, but yes. And so this seed, you pull it over. Now it becomes this anchor, and now you can start saying, where's their feature envy? Where's this getter being accessed? And then it's just mechanical. You just find, where is it used? Pull it in. Where is it used? Oh, it's inside of a bigger method. I'm going to have to extract it, and then I can move it over. And invariably, you pull over 3, 4, 5, 10 different things that looked okay where they were, maybe, or maybe you just didn't have a place to put them. So instantly, once this seed is there, it starts growing and attracting all this behavior. And so then you're just doing extract and move, extract and move, extract and move, extract method, move. And so what you end up with is, so again, sort of back to the blackjack game, you end up with this private list of cards, and you start with a little bit of behavior, right? So we've moved some of the obvious behavior, the things that were directly accessing this list. And then you sort of recursively apply primitive obsession. Say, this value, do we really need to return an int? Because we know where that leads. That leads to comparison and calculation outside of this class. And so we start looking, where is this being used? Oh my gosh, it's being used in all these places. And so you start pulling them in, right? Pulling that thread and moving the behavior to where it belongs. Right? Who's responsible for these things? Pull it into where it belongs. And where you end up with is now a class where all that behavior not only is well named, right? So all these things are named in terms of the domain, right? You can now ask a hand. That's what we want. We want objects where we can query them. Hey, are you busted? Do you push, right? Which is a tie in blackjack. Do you push with this other hand? Do you beat this other hand? Do you equal this other hand? And so we have a display value because sometimes we display the value of the hand. But other than that, we don't reveal the actual value of the hand. This is now private. And so now this is, again, much more testable. Where now we can test it. I mean, you just look at the code and you know it's instantly easier to test. Whereas before it was buried inside of other places. And so by, again, sort of recursively applying this, what is this class exposing? We can basically make it better OO. So we look for public methods that can now be private. If they can just be private, like that setter before, we could make them private. And maybe later we decide what we want to do with that. Are we returning these unconstrained types? Then can we close it off? Can we limit its exposure? What are clients of users of this method? What are they doing? Are they making decisions? Should they be making that decision? And so by really looking at this, it leads invariably to just better OO code, which is what I want, because I don't like OO code just because it's OO, but because it's testable. So that's all I have for you. I'll take any questions that might have come up. So one thing hopefully that will happen is that when you look at Java code and you look at your classes, you will not be able to help but think, is this suffering from primitive obsession? And I'm both sorry and not sorry for that. Alejandro says, what can I say about the tell, don't ask principle? So there's, I no longer remember what that principle was supposed to do. To me, I always come back to objects should in terms of the functionality, the methods that they have, they should either be commands that you're asking it to change its state, or they should be queries, and those should have no side effects in terms of the state that the object is responsible for. And a lot of times we can replace sort of these wide open queries where it returns an int or a string that is, something that we compare against some other string to do some functionality, or list, God forbid. Sometimes you need to return those. Not saying you don't, but that you really want to think about it. And basically stop using getters and setters for your domain objects. I'll have to look at that to remind myself what that is. What is that? Oh yeah, I mean it's the same thing. Yeah. So tell don't ask is basically, instead of asking for something and then doing some operation on it, the object is responsible for its data. This is something that I know there's some folks who feel like, oh, functionals is better than OO, and I think they're just different. But if we're going to do OO, let's do OO right. And objects are behavior plus data, and we should focus on the behavior, not the data. And so if you want to see me rant, come onto my Twitch channel and ask me about how this stuff gets taught in school, because I have quite a rant, because it's taught wrong. It's taught very data focused. And what's interesting is it really fits very well with domain-driven design, in that we need to focus on the behavior that we want, not the data. And that's exactly what it should be. It's like, let's focus on that inventory level. It could have stored it any internal way. That's not what we need. It's like, we need to track information, but we don't care about exactly how it does it. And so we want to truly encapsulate. And so looking at it through this primitive obsession lens really, I think has helped me provide guidance for what do I do to fix this. Question, sometimes refactoring is of awkward intermediate stages where in a sufficiently local scope, things are temporarily worse. Yeah, so I don't know if I want to go through the refactoring, because I don't have the code quite set up to do the full refactoring. One of the things that I'm doing when I'm doing a refactoring, like moving from this list of cards to a hand is I make sure that my goal is clear, right? So just like we have tests for, acceptance tests, how do we know when we're done, right? How do we know when we're done with anything? Well, so here I want to know when I'm done is when, for example, nobody is calling this method from the outside. That's how I know I'm done. Or when the hand is fully encapsulated and there's no more behavior accessing this. And so in fact, that we were just reading in a study group, the Working Effectively with Legacy Code book. And one of the things he talks about is sort of being single-minded about your refactoring. And so I'll often put a post-it note like, what's my goal? How do I know I'm done with what I'm doing? And if I encounter code like, oh, I should fix that, I look at my goal and say, is it in line with that goal? Do I need to do this to reach that goal? And if not, then I write it down. I create a card, I create a post-it, whatever. And later on, I'll get to it. And so that helps me get to this point of really being single-minded and not getting distracted, because it's very easy, especially as you get better. If you're good at refactoring, you're good at smelling, for code smells, it's very tempting to fix these things along the way. One reason I resist that, not just getting distracted, but enough times the thing I would have done goes away completely and becomes irrelevant when I'm done with my refactoring. And so I want to get to that goal. Then when I'm there, then I can look around and do all these other things. Am I exposing too much? Is there other duplication, the typical refactoring things that I look for? But along the way, I don't want to fix things. The other thing is the way I do this refactoring in my class, and the way I teach this is a bunch of steps, very much according to the small safe steps that small changes like GPaw talks about, where I may set up a little bit of scaffolding, a little bit of code, because the other thing I want to do is make sure along the way all my tests are passing. The code is compiling, my tests are passing. I get nervous when I haven't seen it compile or let alone run the tests for 10 minutes. I get a little nervous. Once that starts getting to 20 minutes, I'm like, I've gone too far, let me back up. And so that's something that I think you get with experience, but I want to make those small changes along the way. And I lean heavily. I mean, again, it's like, look, we've got this super powerful tool. I love IntelliJ. If I could love a tool, it's the one I love. And even this past year, I've learned a lot about it. But we use such a tiny bit of it. All those automated refactorings are so powerful. And allow us, not necessarily that they don't make mistakes, because there are bugs and maybe there's a mistake, but allows us to think differently. It allows us to make safer refactorings than we might otherwise do. And so leveraging those, and sometimes the code looks a little ugly along the way, but keeping that goal in mind, really helps. And maybe have to put up a little scaffolding to cross to the next step. But then I know I'll come back and remove that. Barry, as a teacher, says difficult to teach OOP. Students misunderstand it, and I think that's because it's taught wrong. So I study how people learn. I study a lot of objects, the whole objects first versus objects late argument, and so on. And again, we could talk a whole lot about that. Alejandro asks, how do I organize the code with all of these classes? I tend not to use static inner classes very much, but in terms of code organization, if it gets big, I look at sort of feature-oriented things. Since there's a higher level design that I'm always thinking about, which is hexagonal architecture, which I've given a separate talk on, and I organize my code that way. So you might see something like this in terms of code organization. So these different colors show the different aspects of the code according to hexagonal architecture, but these are all my domain classes. And you can see I'm in the middle of actually refactoring towards primitive, getting rid of primitive obsession in this particular case. But I like to organize in terms of hexagonal architecture. So I have a core domain, and then I organize that according to what features or what aspects, sort of a component type of thinking about it. But also, if it gets too large, I might be concerned that the whole thing is too large. So, IntelliJ is magical. You can color code. Yeah. Other questions or comments? And so, as I mentioned, this is basically from an online class that I teach. So you can find out, and if you're interested in that class, sign up. You'll get a discount. Go to maketestable.com. That'll lead you to a subscription page, and you can sign up for the email list. And this is part one of this, which focuses on this more. You will be so sick of primitive obsession by the time you're done with that, in a good way. And so the next class is happening in December. And as I mentioned, I also live code on Twitch, so you can find me there. And with that, if there's nothing else, also Discord, feel free to hit me up on the Discord, find me there. We got good discussion about these things. It's all my Twitch community and class community. And there are a couple of people who are hanging out here who've attended that class, so actually 3 of them at least. And that's it. Thank you very much, everyone.